Hello, everybody, and welcome to our webinar today, Global Applications and Data Sovereignty with PostgreSQL. We are about to get started. As we do, let's just go over some housekeeping items. The first thing is the webinar is going to be recorded, and you will also get a link to the recording later in your email. Second, this webinar is meant to be interactive, and there are several ways you can participate with us during the webinar. First of all, in the bottom right corner, you'll see a questions tab. You can ask a question at any time, and we will answer all the questions at the end of the webinar. You will also see some polls come up from time to time, and please answer those polls on your screen as they come up. And finally, you can also chat with us if you like with using the chat button. With that, I'd like to turn things over to our moderator for today, Sushant Rao. Sushant, all yours.
Great, thank you so much, Ramaz. So thank you everyone for joining us today. So let's start by having the speakers introduce themselves. Ashok, would you mind introducing yourself?
Sure, thanks, Sushant. Hello, everyone. My name is Ashok Mahajan, and I'm a Senior Partner Solution Architect with Amazon Web Services. I'm part of the global startup team that works with startups, and that too security startups, in their enablement journey on AWS. I have over 18 years of experience, mainly in the security space, focusing on identity and access, data protection, and application security across multiple domains.
Excellent. Thank you for joining us today. And next we have Renisha. Renisha, would you mind introducing yourself?
Sure. Thanks, Sushant. Hello, everyone. This is Renisha Marar. I am a database specialist solutions architect, and I specialize in RDS and Aurora PostgreSQL. Well, I have my sunglasses on. Please pardon me because I have an ongoing eye infection. This is not how I usually turn up for webinars, but I help customers. I have over 5 years of experience, and I help customers with their PostgreSQL workloads on both RDS and Aurora.
And Renisha, thank you for joining us. And I will say that the sunglasses go well with talking about security and privacy, so well in keeping.
That's right.
We just need a little hat so you look like a true detective. And last speaker is Billy. Billy, would you mind introducing yourself?
Yeah, thanks, Sushant. So Billy Van Cannon, I'm a Director of Product Management at Baffle. I've been here about 2 years. And for the last 15 plus years, I have been in various aspects of cybersecurity, including network security, aspects of identity and access management, and encryption.
Great. So let's start off by talking about the agenda we'll cover today. We'll start off with talking about resilience for global applications with AWS. Then we'll talk about the Amazon Aurora Global Database and how it's used for global applications. Then we'll talk about data sovereignty regulations and then a solution to comply with data sovereignty. Lastly, we'll do a demonstration, go through some case studies, and finally a Q&A. So if you have questions that come up, you should see in the bottom right a little Q&A widget. Go ahead and put your questions there and we'll try to address them at the end. So with that, let me turn it over to Ashok to talk about resilience and AWS global infrastructure. Ashok.
Thanks, Sushant. Next slide. Before we dive into the agenda and talk about resilience in general, let's do a quick poll and see how many of you are actually looking for options to protect your data when you're thinking of global application deployment. You can choose options from the poll button with option yes or no. If you're actively looking for a global data application security strategy, click yes. If not, just select no. I'll give you a quick 30 seconds to respond.
Give me 1 second to bring up the poll question because I don't have it yet.
While Hamas is bringing this up, think about your application strategy, whether it's happening right now or you're thinking of any future deployments. Think about how you want to scale your application and what are the data specific needs that you have when you think about these applications. It's good. So we have over 70% of people who are actually looking for a data protection strategy when you think about global application deployment. So that's a good number. Let's go back to the next slide. So before we talk about global applications and the architecture around it, let's quickly understand the key concept that is resilience. Resilience basically refers to the ability to adapt to changing conditions and prepare for, withstand, and rapidly recover from disruptions. I think we all know that any complex system is likely to have a mixture of small, more predictable failures and larger, more rare failures over its lifespan. Because of this, organizations must expect and plan for system failures and design workloads to recover from these failures in a way that minimize impact to their end user. We cannot talk about resilience without talking about its two key support pillars, high availability and disaster recovery. High availability, usually expressed as 4 nines or 5 nines, refers to the ability of a system or an application to remain operational and accessible even in the event of failures. Disaster recovery, on the other hand, refers to the policies, tools, and procedures that enable the recovery or continuation of vital infrastructure and systems following a disruption or a disaster. The mental model that you should consider as we go through today's presentation is to think about how can you build system to be highly available and recover if you run into these rear failure scenarios, and most importantly, how data plays a crucial role in your global application strategy. Next slide. When we think about resilience, one word that comes to my mind always is multi-region. A multi-region architecture in AWS basically refers to deploying your application and its component across multiple AWS regions. We'll talk about what that means in terms of AWS, like multi-AZ and multi-region in a bit, but let's first understand why resilience is important. First, unplanned system downtime costs Fortune 1000 companies anywhere between 1.2 to 2.5 billion annually. Second, in today's digital age, expectations from customers have shifted towards an always on, always available mindset. Customers really depend on the services to be available all the time, and when it's not, it negatively impacts your organization's brand. So, if you look at this example, we want users in San Francisco to connect to US West and New York to US East. But in case of an issue or a disaster, we want users from San Francisco to fail over to US East without causing any disruption in the services they were actually using. Next slide. The second reason in this segment is basically the geographic distribution of customers, which I think we all can relate to in today's world. So if you have global users, we want US West users to go to Oregon, like New York users to go to Virginia, London users to Dublin, Australian users to AP Southeast. And this is especially critical for latency sensitive applications. Another important reason when you think about these global applications is the need to meet your local and regulatory requirements like GDPR in European Union, German data privacy laws, or even the privacy laws we have in US like HIPAA. All of these reasons combined require a robust data strategy to support your global applications. Next slide. AWS basically enables to meet these requirements with AWS Global Infrastructure, which comprises of availability zones and AWS regions. Many of you might be familiar with these terminologies, but for someone who is not, an availability zone consists of one or more discrete data centers, each with its redundant power, networking, connectivity, and housed in a separate facility within a single region. AWS region, on the other hand, are separate geographic locations that consist of multiple physically separated and isolated availability zones that are connected through low latency, high throughput, and highly redundant networking. As of today, AWS Cloud spans 105 availability zones within 33 different geographic regions. So whether you need to deploy your application workload across the globe in a single step, or you want to build and deploy a specific application closer to your end user, AWS provides you the cloud infrastructure where and when you need it. Next slide. When you work with AWS Cloud, you basically operate in a shared responsibility model. And for resilience also, we follow the same model, where AWS is responsible for resilience of the infrastructure that runs the different AWS services. whereas you as a customer are responsible for resilience in the cloud. What that basically means is your resilience responsibility is driven by the different service that you use. You are responsible for running the workload in AWS, including any configuration options. As an example, for a managed service such as Amazon Aurora Database, AWS operates the infrastructure layer, the operating system, the platform, and you access the endpoints to store and retrieve the data. So in this particular example, you are responsible for managing the resilience of your data, including backup, versioning, and any replication strategy that is required as part of your global application requirements. Now let's hear from Renisha how Amazon Aurora Global Database is designed for globally distributed application, allowing a single Amazon Aurora database to span multiple AWS regions and meet your global application requirements. Over to you, Renisha.
Thanks, Ashok. Well, in this increasingly globalized world, modern applications must cater to these users who are spread across, say, various regions, often which requires real-time access also worldwide. Now, ensuring data consistency, low latency, and resiliency across these distributed systems is pretty critical, right? And traditional databases or traditional database architectures struggle to meet these requirements. However, at Amazon, we have a popular offering, which is Amazon Aurora Global Database. It seamlessly replicates your data across regions, thus enabling you with global scalability, with consistent, low latency data access. But before I dive deep into what Aurora Global Database is, and how this technology can, transform the way you would manage your databases in the global context, I just want to bring up another quick poll over here. So what we want to know is, what are your current issues or the issues that you think that would impact your global application strategy? And here are our three options. Is it the lack of data sovereign controls or limited resources and knowledge around this global application strategy, or if you're unaware of the global database concepts? And you can select all that is applicable for you, but you don't have to stick to just one option out of these three. I'll just give it. Okay. Oh, wow. All right. I'm actually glad to know that people who are attending the webinar, they are aware of the global database concepts. That's great to know. And limited resources and knowledge has topped the list. And that's what we are doing this webinar for. And I assure you, a lot of these issues would be resolved as part of this, presentation that we have today. All right. Having said that, for high availability and disaster recovery, that's HA and DR, across multiple AWS regions, with Amazon Aurora, we have two options, as you can see. The first one's the cross-region read replicas. Now, this option is only available for Aurora MySQL compatible edition, wherein you can have up to 5 cross-region read replicas per source database cluster. The replication is logical replication, which is MySQL bin log replication. And there can be higher replication lag due to longer network channels between regions. But the second option is what we are interested in and looking at it today, which is Aurora Global Database. Again, this is available for both Aurora MySQL compatible edition as well as Aurora PostgreSQL compatible edition. What it does is it uses a dedicated purpose-built replication infrastructure and replicates a primary Aurora database cluster to up to 5 secondary read-only database clusters across different AWS regions. And what that gives you is basically it enables low latency global reads as well as disaster recovery options across AWS regions. So Aurora Global Database offers you a robust and low latency solution for global high availability and disaster recovery with physical replication across multiple regions. Now, before I talk any further about how things work within a global database, here are the 3 primary use cases that I like to talk about when speaking about Aurora Global Database. The first one is disaster recovery. So Amazon Aurora Global Database, it allows you to create a secondary database cluster in a different AWS region, which can, then serve as a standby for disaster recovery purposes. So say in case of a regional outage or disaster, the secondary database cluster can be promoted to take over the workload, thus, minimizing downtime as well as data loss in a global application context. Now, the second use case is low latency local reads. So with Aurora Global Database, you can distribute your read workloads across multiple, AWS regions, and by creating read-only replicas in those regions. So applications, say, running in these different geographic locations can read the data from the nearest read-only replica, thus reducing latency and improving the overall experience and also the performance for such global user bases. And the third one is to enable global follow the sun application. Basically, Aurora Global Database supports this follow the sun model, where you can distribute your application workloads across multiple regions. And I'll talk in much more detail in the later slides. I do have a reference architecture of one of our customers as well, who are currently following this global follow the sun application model. All right. So like I said, Aurora Global Database allows a single Aurora database to span multiple AWS regions. It replicates your data with no impact on database performance, enables fast local reads with low latency, and provides disaster recovery from region-wide outages. So whenever you create an Aurora cluster, what we do is we do storage-based replication by using dedicated infrastructure, which leaves your database instances fully available to serve the application workloads. So a global database has a primary cluster in one region where your data is written, and you can have up to 5 secondary read-only clusters in different regions. Each secondary cluster can include up to 16 Aurora replicas. So you issue write operations directly to the primary cluster in the primary region, and replication from the primary to all the secondaries is all handled by the Aurora storage layer rather than by the database engine. And thus the lag time that you would see for replicating the changes with a global database is pretty minimal. Over here in this example, as you can see, we have a primary region in the Ohio region, and application, you can have an application A, say, running against this primary, probably doing both reads and writes. And then we have the storage tier, which replicates the data to North Virginia, Oregon, and as well as Ireland region. And say you can have a separate application B that you use only for reporting use cases, which can read from the secondary cluster that's closest to the application B, say, for example, Oregon, thus leveraging, low latency reads. So how does this exactly tie into being a cross-region disaster recovery option, right? Say if your primary suffers a performance degradation or outage, you can promote one of your secondary regions to take read-write operation responsibilities, and an Aurora cluster can recover in less than a minute, even in the event of a complete regional outage. So that provides your application with an effective, RPO or recovery point objective of 1 second, and a recovery time objective or RTO of less than a minute. Thus, providing you a strong foundation for a global business continuity plan. Here's a quick comparison between physical versus log-based asynchronous replication that we do in Aurora Global Database versus logical replication. Now, Aurora Global Database supports up to 200,000 writes per second. The left-hand side on the screen that you see, it shows logical cross-region replication based on MySQL binary logs, while the right side depicts the Aurora Global Database's physical replication. The x-axis represents time and the y-axis represents QPS, which is queries per second. So with logical replication, you can see as the queries per second shown in pink, as it increases, the replica lag on the secondary y-axis keeps growing. At around, say, 50,000, QPS, the replica lag approaches to be 10 minutes, meaning that the secondary cluster has data up to 10 minutes older than the primary. thus impacting the overall, RPO of your global applications. But on the other hand, with Aurora Global Database's physical replication, QPS can reach up to 200,000 writes per second, while the replica lag stays well below 1 second. So this minimal lag that you see positively, it impacts both RPO and data freshness on the secondary cluster. So while talking about the primary use cases, right, I'd mentioned about this one of the use case for global database is that it supports follow the sun model, where you can distribute your application workloads across multiple regions. And this is the reference architecture of one of our customers' global database, Aurora Global Database, follow the sun, strategy that we have. So say during your business hours in one region, right, applications can write data to the primary database cluster in that particular region. For example, over here, let's say the trading starts in Sydney, and the primary region of the global database is currently AP Southeast 2, as shown in this, as depicted in this picture. But as the workday transitions to, progresses and transitions, the primary region would also transition to another region. So the primary database cluster can now be promoted in this new region, enabling seamless global operations and also minimizing downtime. For example, the trading now moves to London, and hence we can seamlessly switch our primary to be now EU West 2 to handle the local traders, say during the European market hours, using the switchover capability that we have within the Aurora Global Database. And lastly, again, as we move along, we can shift the primary region to New York when the trading moves to New York, and the primary region now is US East 1, as shown and highlighted here. And again, this can be achieved using these seamlessly using the switchover capability that we have. Also, before I wrap up, I do want to mention that meanwhile you're switching these primaries, right? The secondary clusters in these other regions, you can also have them not to be just read-only replicas, but you can also have them do these write operations using the write forwarding capability that we have in Aurora Global Database. By that, what I mean is you can write against your secondary cluster, and using write forwarding capability, it would automatically forward and apply the changes or the write operations to the primary cluster. So all in all, with global database, its ability to span multiple regions and organizations can just achieve robust disaster recovery, low latency global data access, and also follow this seamless follow the sun operation for their mission critical applications. But before I tune in and I hand it over to Billy, I do want to go over this quick poll again, which is now that I've mentioned about the different use cases that you can leverage Aurora Global Database for, what do you think would be your primary use case that you would choose Aurora Global Database for? Can you let us know? Would it be disaster recovery, local reads for global application, or both? That's good to know. Over 70% of the people have mentioned it to be both. And definitely do check out Amazon Aurora Global Databases. And now I'll hand it over to Billy to help us understand how to comply with the data sovereignty regulations in the global context.
All right, thanks a lot, Ranishi. All right, so AWS has done a fantastic job of providing a global infrastructure that we can use for HA and DR. But now, since we're talking globally, how do we comply with data sovereignty regulations? So Baffle has many goals along with this. First of all, is we want to allow maximum scale and compatibility with Aurora Global. Now, of course, we also work with standalone databases and RDS, but this is the webinar about global applications. So we're going to talk about that specifically here. We also have a goal of no application code changes required. If you think about an old application that you have where the original developers may not be around anymore, it may be in a programming language that your current developers don't use, Or worst case scenario, you're talking third-party applications like Tableau, Power BI, or your ERP systems that you can't change the code for. So that's a big goal for Baffle. And then we also want to use encryption. And it's very important when we talk about encryption, not only to talk about like which algorithm to use and how you can have the most random seed possible, and who can access the keys. Those are all very important. But a big part of this presentation is where and how you implement the encryption is very important. And so we want to use encryption to meet all these additional goals. We want to provide data sovereignty. Specifically for GDPR, we want to convince the European Union that the US government can't access EU PII data, PII being personally identifiable information. We want to protect the database against attacks, even if they get the DBA credentials. And so like Snowflake's been in the news, they weren't breached, but their customers were, the data that Snowflake stored for their customers. And they said, well, they used weak passwords, they got phished, they didn't implement MFA. These things are all true, but I guess what Baffle would say to that is, why do we still trust our end users with security? They're never going to care. It's just the fact of life. They're accountants, they're support, they're engineers. Not everybody works on security every day, so we have to move past that. Next thing is, how do we convince the legal and compliance team that even AWS can't access the data? Now, this is mostly theoretical. AWS has layers and layers of protections against their employees accessing the data, but plenty of people have been all excited to move to AWS or any cloud vendor, and then the legal or compliance team comes in and says, well, yes, but in theory they could get that data, and therefore we're not going to allow you to move. So Baffle can help that process of moving to the cloud. And then finally, we want to allow SaaS, our own customers and their customers, Sony SaaS tenants, to provide their own keys for encryption. And this provides them with ultimate control over their data. They revoke the key, nobody else has access to that data. All right, so before we dive into that, I just want to get an idea. Of course, I'm going to talk about GDPR, but I'm also curious, what other data privacy and regulations are you responsible for? And go ahead and choose all that apply. If it's country level, so GDPR, but that also includes like the Latin American ones, China's PIPL, CCPA, or any other state besides California that you're concerned about right now. PCI is for anybody who takes credit cards, and HIPAA is for anybody who is working with medical information in the US. All right, they're coming in here, and it's GDPR, of course, is going to be the main one here, but it looks like people are working with CCPA and HIPAA as well. PCI came in kind of low, but which I'm kind of surprised about, but given what we're talking about, I guess it makes sense. All right, cool. So it says about 60% GDPR and another 20% for CCPA. So these governmental level personal information requirements. So fantastic. All right, so like I was talking about, I'm going to dive into GDPR, and GDPR does not have data residency requirements per se, meaning you do not have to keep the data in the EU. You can put it in other countries, but you have to meet one of these three safeguards. So adequacy, safeguards, commercial contracts in Article 46.1, and then supplemental technical controls. And I'll go ahead and go through all of these. So the first one is adequacy. And what they're talking about is, does the EU trust whatever other government that you're keeping the data in to provide similar protections? And that similar is under, it isn't well defined. And this, as you can tell by this timeline, has started way before GDPR. In 1998, the European Commission created this directive on data protection, and they got together with the US and created the Safe Harbor Project. And the European Commission approved it, and that was the agreement for adequacy between the US and the EU for many years. Of course, after 2000, 9/11 happened, and the Patriot Act came along, and people really didn't realize the implications of that until 2013, when Edward Snowden's leaks came out, and that alarmed everybody, and they saw how powerful the US Patriot Act is in collecting people's data. And so it's literally went back and forth between the US and the European Commission and the CJEU. So the European Commission will approve what we agree to with them, and then the CJEU, which is the European Court of Justice, will invalidate it. And you see it's gone back and forth many times. the last iteration in 2022, President Biden issued an executive order. The European Commission approved it. And then it was immediate, like they approved it in July of 2023, and then it was immediately challenged, and now it'll end up in front of the CJEU again. So the bottom line with this is adequacy is going to be a question mark for the foreseeable future. So what about the next one, safeguards? Here, I'll go back. Safeguards means you set up commercial contracts that provide these protections. So let's say you want to set up a SaaS service, and you set up contracts with your customers and your vendors, and you all agree on who's responsible for what and what the redress is and everything, and it closely resembles GDPR. That would be great, except that if the US government can come in and invalidate that aspect of the contract and still demand the data, then it doesn't do any good as far as the EU is concerned. So until the first part's taken care of, that doesn't help either. So that leaves the last part, and that's supplemental technical controls. And specifically, we're going to talk about encryption. So GDPR, and this is true in all the other privacy regulations as well, the Latin American ones, the China ones, the US individual state ones. And they say if there's a breach, you have to report to the authorities so that you can be fined and so that we can learn from it. And you also have to report to the people whose data was stolen. But they all have this loophole, and it says, unless that data was encrypted. And so Article 34 specifically says encryption. CPA says unless it was not encrypted, but they both mean if that data was protected, you do not have to report it. You're not going to be subject to fines, and you do not have to tell the users. So that's a huge loophole that we can use, and it goes even further. The European Data Protection Board created this paper called Recommendations for providing supplemental controls. And the first one is use case 1. And use case 1 says, what if I want to move my data to the cloud in a different country? How do I ensure that that country's government can't get access to it? And how do I ensure that the cloud provider can't get access to it? So that's specifically what they point out, and they say that encryption will work, but it has to be done correctly. All right, so now I'm going to dive into what Baffle does. So let's say this is your starting point. You have an application talking to the database, and the data is moving back and forth in the clear. Now, even if you have TDE, which is transparent data encryption, or FDE, which is full disk encryption applied. TDE means the database does it. FDE means the underlying operating system does it. In Amazon's case, you can flip a switch, and their underlying hypervisor will encrypt the data before it goes to storage. But the thing I want to emphasize here is the only threat vector that protects against is somebody physically stealing the hard drive and putting it in their own computer. The DBA still has access to the data. The cloud provider still has access to the data. All the applications still have access to the data in the clear. So anyway, in any case, this is our starting point, whether you have disk encryption enabled or not. Baffle is a reverse proxy that's placed in line between your application and database. It operates at the network and the SQL session layer of your OSI stack. But what that means is, other than changing the application connection string from directly to the database to the proxy, your application is completely unaware that the proxy exists. And so at a high level, what it does is when the application writes data to the database, the proxy will encrypt it. And then when the application reads from it, the proxy will pull that data, and it will decrypt it and apply access controls on it. So this is how we implement encryption outside of the database, and we provide the access control to the application, all without code changes to the application itself. In addition to that, we provide the key management. So we actually go out and connect to the keys. We use the standard industry method of a two-tiered approach. So there's data encryption keys, which actually encrypt the data, and then there's key encryption keys, which encrypt those. Oops. And then we also have a management console called Baffle Manager, and that's how you set up the policy configuration and monitoring of all the different proxies. Let's see here. There's one thing I wanted to mention about that. A big advantage here is the customers don't have to provide any of the key managements. And then when you were talking about auditing, say there's a whether it's a GDPR audit or PCI audit or however it's done, you can just go into Baffle Manager and show the policies. You don't have to pull your application apart and show them the code where it shows the actual application controls. Most people probably don't know what I'm talking about unless they've actually went through an audit and had to go through that process. But in any case, you can just look at the policies in Baffle Manager. It makes passing your audit a lot easier. All right, and so the next aspect to that is talked about before about how we only, if you have TDE or FDE, it only provides protection against physical theft of the hard drives. Well, we still have that with Baffle because the encryption is outside of the database, so now anything saved is there. But not only that, let's say the database admin credentials are stolen. We're protecting against that as well. Let's say you're worried, your legal or compliance team is worried about AWS somehow getting that data. They cannot get the data because it's encrypted at the database level. I think one of the aspects here, especially with the DBA, is every privacy and security framework has this concept of least privilege, and it says you should only provide access to the data that's required to do your job. And I've never seen anybody fail an audit because their DBA had access to all the data. The employees, social security numbers, their customers' credit card numbers. The DBA has access to everything, and that is because it just technically wasn't possible before to separate those things out. But now with Baffle, it is possible, and that covers a huge gap in most of these frameworks. Not only do we provide least privilege for the DBA, they can go in and do their job now, but they can't access the data. We can also provide access controls to the applications themselves. So kind of pop back here. Here I was just saying, have an application generically connected to it, but you can have multiple applications connected to Baffle or even multiple shields. But in any case, you can set up access controls. So let's say human resources here, we decided they should never have access to the credit card number, but they do need the social security number because they're setting up people's benefits. Support, they don't need access to either one in entirety, but they do need access to the last 4 digits so that they can identify their customers. And then this remote user, we're saying we can't control that well enough. We're not going to let them have access to anything. This is the kind of fine-grained access control that you can implement with Baffle in place. Oh, and I also have these IP addresses. You can further add a layer that says, you only connect to given IPs or given subnets with using CIDR notation. So there's lots of different controls you can put in place now that you have this proxy in the middle. There's yet another control, and this is going to get to the heart of what we're talking about here, and that's, we're calling it record level encryption. So again, on the left side, I have a multi-tenant application, and it's talking to a database on the right, and it's got Baffle in between. But now Baffle is looking at specific rows in a table. And when the application says, okay, tenant 1 is wants to write to a credit card number to their row in a table, the shield will go ahead and reach out to that key, and that key can access to that key can be provided by the end user, the end customer themselves. And we don't care if it's AWS KMS or HashiCorp Vault or Azure Key Vault or where that is. We will reach out to it, grab those keys, encrypt the data as it comes in, and decrypt it as it comes out, assuming that a tenant is logged in. So this is how we can provide isolation between tenants and also between regions. This is very similar to what I just talked about. But instead of row level within a table, this is logical database encryption within a database instance. So you have your instance, and then you have logical databases in between them. You can set Baffle Shield up to encrypt all the sensitive data within a given logical database per tenant. This is a little bit of a side note, but I just want to be clear on this. When you say bring your own key, a lot of times this is what Baffle is referring to as far as the row level or database, logical database encryption. We're talking about bring your own key. Amazon might be talking about the ability for a customer to generate their own key material and then import it into a KMS. Okay, so that's what they might be referring to with bring your own key. When Baffle brings it up, talking about the row level encryption or the logical database encryption, we're just saying you or your end users can provide access to the keys wherever they are. We don't care how they were created or who created them. We just say, give us access to whatever that key is, and that's bring your own key as far as Baffle's concerned. Okay, so given all that, I want to go back to the Aurora Global pictures that Ashok and Renishi showed. And, we got this worldwide setup with Aurora Global, and we got one in the US, one in Europe, and one in Australia. So how do we, on top of this, create multi-tenant applications where we can isolate the tenants and provide geographical separation as well? So when we talk about tenant isolation, AWS had a paper that I read, and I pulled out some parts of it. And basically they're saying it goes from, you can do it with the silo method clear to the pool method. And the silo method says for every tenant you have, you just duplicate all your infrastructure. So if we go back to that last one for the silo method, you create this for your first tenant, and then your second tenant, you would duplicate this entire set of infrastructure. And for your third tenant, you do it again and so forth. So obviously this is going to provide good isolation, tenant isolation, but it doesn't do anything for costs. You're not getting the scale you would expect from a SaaS application. And also it's not adding any additional security. It limits the blast radius, and then if one of them gets, a attack, then at least all the others aren't, but it still isn't doing anything to protect that in the first place. Then clear on the other side is the pool method, where it says, like I showed in those other pictures, you have your tables and every row represents a different customer, or set of rows represents a different customer. That way you can take advantage of maximum scale of your system and keep your costs low as well. But how do we go ahead and implement this? So continuing with that paper, AWS talks about you can enforce it with a database. Postgres has this feature called row-level security. And this literally up in the top left, that's the SQL command to enable it and then tell it which tenant you're on. But it's still just an access control, but not using encryption. So it's not protecting against the DBA. It's not protecting against your cloud provider. It's not protecting against the government or any other breaches. It's just isolating the applications themselves. So the other option you have is build it all yourself. So in this picture, everything in gray and blue is additional code you have to write on top of your application. So then there comes a problem of, okay, if I have multiple applications, do I tell every application team to build their own, or do I create a new team that has to centralize it? Well, Baffle does all this for you, and what's not even in the picture is encryption and key management. So Baffle does everything in this picture and more. So what I want to do is simulate this picture. I kind of zoomed in on the US and Europe from AWS's pictures, and I've placed Baffle Shield in between the applications and the Aurora Global databases. And also I'm showing that Shield can be connected to whatever KMS you choose. And in this picture, the US has all the tenants with numbers, so tenant 1, 2, 3. And in Europe, they have tenants A, B, C, etc. I did modify this a little bit in the demonstration I'm going to do. Instead of having an application, I'm just going to use dbeaver here on my laptop in Chicago. And I'm using AWS for all of these because I could set up all that other stuff, but wouldn't really show well in the demo. And I'll get the point across anyway by showing what we can access. So this is what I'm actually going to demo right now. So let me share. All right, move this off there. All right, so you should be able to see my browser. And I'll go ahead and start off with showing Aurora Global. So I have this Aurora Global Postgres database. I have my primary right now is set up in the US. So I hope you can see this. I'm trying to make it bigger. Oops. So the primary is in the US. So we've got the writer instance on in US West 2, which is Oregon. And then also a reader instance. And then in the EU, we have 2 reader instances. And of course, if we were to switch to the EU, then one of those would become a writer instance. Over here, this is Oregon, US West 2. I've got my US instance of Shield. And then in here, this is Ireland. I have the EU Shield instance. Okay, so now I'm going to go to dbeaver. And it's I know it's impossible to see this. I've never figured out how to make this bigger, but I've got 4 connections set up. The first one is a direct connection to the Aurora EU instance. The second one is a connection to the EU Shield instance. The next one is a direct connection to the US Aurora Global instance, and then another one is to the Shield instance in the US. So I'll go ahead and start in the US, and we're going to pretend here that it just went live today, and the first day happened in Europe. So they were the primary, and they got their first customers in there. So if I go ahead and hit, try to look at it, this is through the US Shield. All these tenants are, they're, A, B, and C, they're all letters. So that means they're European, and that means this Shield can't see them. And so the way I've got it set up for it to recognize the tenants is setting a session variable. We have multiple different ways of determining this, but the session variable shows the best in a demo because I can literally show you I'm setting this variable, and then you can see what happens after that. So I'm in the US, and let's say I set to a US tenant, and I select from here. Well, there's no US tenants in here, so obviously that's not going to work. So let's say I set it to tenant A, which is a European tenant. And I say, okay, give me that information. Again, this is through the US Shield. And I collect that. Well, it's not showing anything, even though I already set it to A, because the US Shield has no idea what the tenants and the mapping of the tenants to the keys are for the European side. And I can even show that in Baffle Manager here. So here's the data protection policy. This is Baffle Manager. Here's a data protection policy for the US. And we go to tenants, and it's 1, 2, and 3. There's no A, B, or C in here. So this is how you would pass your audit and say, look, there's absolutely no access for anybody in the US to get those European tenants. Okay, so now what I'm going to do, I'm going to go back to dbeaver. So it doesn't have access, and I'm also going to show that if I go directly to the database in the US and do the same thing, clearly that's protected because phone's ringing. You can see here actually even the encrypted data, the random looking bits. And then same thing if we go to the EU and check out directly to the database, same thing. It's encrypted at the database. So now your DBA doesn't have access to the data. AWS doesn't, the US government, nobody has access to the data by going directly to the database. All right, so now let's go back to the Shield and let's say, okay, now the US is live and I'm going to go ahead and start entering tenants from the US. So I'm going to set the tenant to tenant 1, and then I'm going to go ahead and insert information for that person or for that tenant, and then tenant 2. And I'm just going to go ahead and enter some data here for some different tenants. And then I'll add another one for tenant 1 here. So this is going through Shield, and on the way there, it's encrypted with those customers. And so now when the last session I set was tenant 1. So if I go ahead and look at the database, it will say, oh, here's tenant 1. And I know those keys, and I know that you have permission, so I'm going to go ahead and allow access to those. And if I want to see one of the other US tenants, then I'll go ahead and set the variable for that. And then do the same thing. And now I see tenant 2. Okay, so now let's go ahead and look back at the direct connection to the US database. Or you can see they've been entered, but they're encrypted. Let's go to the database in Europe and see that Aurora Global is doing their job. Absolutely, it already copied them over and it's encrypted, so people in Europe can't see it. Now let's go to the EU Shield. Okay, now if you remember, that's where the tenants A, B, C were added. So let's go ahead and look at that. Let's set it to tenant A, and then we'll select that table for tenant A. Okay, there we go. So now you can see all the tenant A information is decrypted, but none of the others. Well, I don't know. What if we want to be sneaky and try to check out some US data here? I just set it to tenant 1 because the European Shield has no idea what any of the numbered tenants are. It can't provide any of that information. All right, so that's that. Go ahead and stop sharing. That's the demo. And how do we pull the slides back up? Here we go. All right, and so that's what I just demoed right here. So I had dbeaver making the connection to Shield. I also had connections directly to the database to show that they were encrypted there, and that the transfer had happened very quickly. And then I showed how we can provide not only tenant isolation in each location, but completely provide data sovereignty between the US and EU. All right, and then from there, I'll go ahead and turn this over to Sushant. Looks like we have a poll.
Yep. So Hormaz, if you can ask the poll. So given what you've seen of the demo, would you like to try it? So click either yes or no, click your vote. It's a good way to kind of just see if the demo resonated with you. And then with that, ooh, Billy, I think you still have 2 more slides on the case studies.
Oh yeah, sorry about that. Yeah, so we actually have 2 different case studies I wanted to talk about real quick. And one of them, this first one, is for financial reporting, and it talks about how tenant isolation is a key aspect. And then the other one talks about data sovereignty. So here we have a Baffle customer, and their customers are huge tier 1 banks like Bank of America, Citibank, those guys, right? And they do financial fraud, risk, and compliance reporting. They're a SaaS for these big banks. And these big banks have 2 aspects to them. One, they say they want BYOK in the sense that AWS is talking about, where they have to use their own key material. So they got to load their own key material into whatever KMS we're using. They also want isolation that Baffle provides in BYOK, and saying, okay, we loaded those keys wherever they're at, but now you have to use them as well. So it kind of covers both BYOK aspects. But they had over 3,000 Postgres database instances in AWS, and they had to meet these requirements that these big banks had. So they came to Baffle, and the reason we won this is because they could implement this on their applications without any code changes. It enabled them to maximize scale on their products. They didn't have to create different instances for every different tenant. And then the BYOK gives them control over their own data. And so a huge aspect of that is it's kind of ironic in that the way you can get customers is by telling them how easy it is for you to leave. And all they have to do is revoke the key when they leave, and the data is as good as shredded. It can no longer be decrypted. And that way they don't, if they do decide to leave, they don't have to go audit your infrastructure and try to get guarantees that you deleted their data. It's just they revoke the key and it's gone. And another aspect to this is, let's say, you could even have this in your contract. Let's say the government sends you a subpoena and says, hey, give us all the data you have on Citibank. And you can say, okay, we'll respond in 1 week. And then in the meantime, you reach out to Citibank and say, hey, revoke your key. Citibank revokes their key. Then you go pull the data and hand the encrypted data to the government, and it's out of your hands. So that's tenant isolation, and also protection against any kind of other the government or whoever, I guess, data sovereignty as well. This other use case is another customer where they provide a lot of marketing information and services. They're a SaaS. They represent like 330 global brands. But they're a Canadian company who bought a UK company, and that company had no data controls. And so they wanted to implement those. They had to do it immediately because they needed to pass their audit before they could continue. I've got Postgres all over this presentation because it's into the name of the title, but we also would do MySQL. So they had MySQL on AWS, and they had to become compliant. And then they were able to implement Baffle with no code changes, and they were able to use the different keys for logical isolation for data sovereignty. All right, so now I have to turn it back over.
All right. So just to summarize, the pool method, I should go back. There we go. So if you want to ensure performance and resilience for global scale applications, you can do it with AWS and Amazon Aurora. Sorry, I'm rushing a little bit because I know we're running a little bit out of time. I'll slow down. You can understand data sovereignty and resident requirements for the regions your application is running, and then you can use Baffle to solve the challenge of data sovereignty and residency. So with that, next steps, if you'd like to try it, we have a free self-serve workshop. You can see the QR code if you have your phone with you. pull up the QR code. It'll take you to the page. Or if you want to type it in, it's info.baffle.io/workshops/self-serve. With this workshop, you'll be able to implement data security controls equivalent to legacy databases. So something that you would typically see something like Oracle and Microsoft SQL Server, but you'll now have it in RDS and Aurora. You'll be able to set up controls in RDS Aurora Postgres to meet current and future regulatory requirements. So those are the kinds of things that you'll be able to do. It's self-serve. You do it on your own pace. So it is a great way to get your hands on and see if this would work for you. So with that, I know we have just a few minutes. So I want to cover some of the questions that you have. And it looks like we have a few. Let's see. So first question, can you use Aurora with global generative AI application? Ashok and Renisha, is that something that you could answer?
Yeah, sure. Let me get on the camera. Yeah, so you can leverage Aurora Global Database in the generative AI application space. If you've heard of this open source extension, PostgreSQL extension, which is PG Vector, you can install the PG Vector extension, which is specifically applicable for PostgreSQL workloads, and you can achieve generative AI capabilities such as RAG capabilities, text similarity, chatbots, and so on. And along with that, you can also benefit from the disaster recovery and the global scalability features that comes with Aurora Global Database.
All right, and it looks like we have time for one more question. Oh, Billy, I think this one's for you. It says, with all the separation of data due to regions, how do I run analytics on my application data?
Right. That first use case I talked about, they do financial fraud, and they only allow access to each individual tenant. But we have something called real queryable encryption, which allows operations to happen on the database. So I don't have time to explain it fully, but the idea is you can set up another tenant where they don't have access to any of the individual rows, but they could run, say, an average on a column. That data is processed within the database, it never leaves, and then the answers are pulled back. So if you're interested in real queryable encryption or doing analytics on the encrypted data, then definitely reach out to it.
All right, awesome. So I think we're about at time. So let me turn it over to Hormaz to wrap it up.
Okay, well, thank you everybody for joining us today. And I'd like to thank our speakers, Nisha, Ashok, Billy, and Sushant for sharing their expertise. Folks, as we end here, there's a reminder that you will be getting an email with the link to the recording. And as always, please feel free to share this webinar with your colleagues and friends as well. With that, I hope everybody has a good day, and we hope to see you all next time. Bye, everyone.